Hey everyone, welcome back to another lesson for pre-calculus. Today we're going to be learning about how to solve trigonometric equations. In order to solve trig equations, today we're going to be looking at it by graphing. We're going to be looking at two things: how to find it by using intersections and how to find those solutions by finding the zeros. And so we're going to look at those graphs and we're going to solve some equations and we're going to get those solutions. One thing to keep in mind is that we're only going to be finding decimal solutions today. We're not going to be finding exact solutions, so no pi's, no square roots, nothing like that. All right, so I have my first example here, solve by finding the zeros. And so obviously we're going to be using that zero method here. And we have tangent of x equals sine of x times cosine of x. So we want to see what values of x will tangent of x equal sine of x times cosine of x. So in order to do this, you want to zero out one side. So you either want to be thinking, okay, I want to either make this side a zero or that side a zero. In this case, I want to make the left side a zero just to move one thing. And so I'm going to rewrite the equation real quick. So I tangent x equals sine of x times cosine of x, and I want to zero out the left side. So what's going to make tangent of x a zero? I'm going to have to subtract that tangent of x. So I'm going to subtract tangent of x on both sides, just like this. And I'm going to move it over there. And those are going to zero out. And so on the left side, I'm going to get 0 equals sine of x times cosine of x minus tangent of x. So now that it's zeroed out, now we're ready to graph this. So here are some notes. You're going to want to make sure if you're on a calculator that you have zoom trig and that you're in radian mode. Here we're going to be doing it in Desmos, so I'm going to make sure I have those things happening real quick. Go into my settings. Okay, I'm not in zoom trig, and that's okay, but what I can do here is I can go from negative 2 pi to 2 pi, and my step I'll make it, let's go pi over 2. And my y-axis is fine, nothing special happening right there, but you do see right here at the bottom left that I am in radian mode. All right, so I'm ready to graph this, and what we had was 0 equals. So when I graph this, I'm just gonna put y equals sine x cosine x minus tangent of x. Okay, so y equals sine x cosine x minus tangent of x. And here's going to be something that's going to be happening a lot, is that you're going to be finding lots of solutions and they're just going to keep repeating. What we're finding right now are all of these zeros. So I have a 0 here at negative pi, a 0 here, 0, I got a 0 over there on 2 pi, and I have 0 over here at negative 2 pi. So let me move that over, negative 2 pi, right there. Okay, so I have them all selected right now, and they're gonna keep going. They're gonna keep going endlessly. What we're going to do in this case is we're only gonna be looking at the zeros from negative 2 pi to 2 pi. And that's all we're gonna be focusing on. And so we just want those zeros. So you set the equation equal to 0, and then you find where those zeros are. So let's write those down real quick. So I have negative 2 pi. And then I had negative pi. I have 0 and pi. And then I have 2 pi over there on the right. Now keep in mind, and so I actually changed up what we were going to be doing here. It does say from 0 to 2 pi, but I went in my example from negative 2 pi to 2 pi. That's fine. Whatever the examples tell you to do, stay in that domain. All right, so what we want to keep in mind is that your calculator, depending if you don't use Desmos or whatever calculator you might use, may not give you those pi's. It might say 3.14, or it might give you more decimals, and that's okay. But in this case, Desmos gave us the pi's, but I know on the TI-84s and the TI Inspires, it'll give you those decimal solutions. And in that case, if we're solving by graphing, that's a really good way to get an estimate and check your answer. And that's what we're doing as we move into this unit. We want to know how we can check our answers. So that's the method to find the zeros and solve a trig equation. Let's move on to our next example, where we have to find the same exact answer, but we're going to be doing it by intersection. So in this case, what you want to do is graph the equations separately. So it says graph each side of the equation. So our first equation is going to be tangent of x, and then our second equation is going to be sine of x times cosine of x. So let's put that down. So I have tangent of x here, and then I have sine times cosine. All right, and here is what we're looking for in this case. We are looking for those points of intersection. Where are those lines crossing? And we're going from 0 to 2 pi, so I'll focus only on the range from 0 to 2 pi this time. Okay, and if you're on a calculator that's not like Desmos, you're definitely going to want to use that intersection feature of the calculator. So we're going from 0 to 2 pi, and you want to find all of those intersection points, not the zeros in this case. So where the green and the blue are crossing. So I have one here at 0, I've got one here at pi, and then I have one here at 2 pi. And yes, I know it'll keep going infinitely, but that's why I'm giving us a domain to solve our equations on, from 0 to 2 pi. In this case, our answers are going to be, technically it would just be pi, but I'm just going to write them all down. Our x values would be 0, pi, and 2 pi. All values of those would come out to be equivalent in this expression. So as you're going through this lab, you're going to want to determine which would be the case for solving points for intersection and which would be the case for solving points for zeros. It doesn't really matter. You notice how we got the exact same answers, but depending on which one you do, you're going to want to make sure that you're finding either the zeros or the intersection points for those answers. As you're going through this, if you do need help, please let me know. I'm Mr. Hernandez, and I'm always here to help.